Hello, welcome. Let's have a look at problem 1 from the Random Math Olympiad team selection test. It says, find all positive integers mn with m plus n equals 2019, for which there is a prime p such that O over m plus 3 plus 4 over n plus 3 equals 1 over p. Now, if you want to give this problem a try, feel free to pause the video and try it on your own. Then when you're ready, keep watching. Now, to start, I'm first going to use a substitution. I'm first going to let x to be m plus 3 and y to be n plus 3. Now, from here, you can immediately see that x plus y equals m plus n plus 6, which is just x plus y. M plus n is 2019 as given. So 2019 plus 6 is 2025. So x plus y is 2025. Now, from the given expression, you see that 4 over x plus 4 over y equals 1 over p. Now I'm just going to find the common denominator and move things around. So I get 4 times x plus y divided by xy equals 1 over p. Now, cross multiplying on both sides, you see that 4 times x plus y times p equals xy. So here we can immediately see that xy is 4 times x plus y. X plus y is 2025, so it's 4 times 2025 times p. So we have this system of equation. Now from here, I can point out that x and y should satisfy. No, I don't even need to should satisfy. X and y satisfies because you have the product and sum, their product and sum. So x and y satisfies for our solutions to the quadratic equation. X and y satisfy quadratic equation. Quadratic equation. Let's say t squared minus x plus y t plus xy equal to 0. And that is because that is true by the Pieta's relation, which says that any quadratic polynomial can be expressed in terms of sum and product of its roots. So in this case, we have the sum of x and y and the product of x and y, which from here we can immediately point out that x and y satisfy this quadratic equation. So if you replace t by x, you can easily see that this left-hand side will be 0. And similarly, if you replace t by y, you also get 0. So using from here, you can see that t squared minus x plus y is 2025. T plus 4 times 2025 times p equal to 0. Now here, you can just use the quadratic formula and to find the value of t. So t1, t2 is 2025 plus or minus the square root of. Here, it's easy to observe that 2025 is a perfect square, it's 5 squared. So if you take 2025 squared, you're just squaring a perfect square. So 45 squared, which is just 45 to the 4th power. So this is 45 to the 4th power minus 4 times 4 times 2025. And let me write it as 45 squared So times 45 squared times p, this, and then divided by 2. So from here, I can just see that this will be 2025 plus or minus. Here, inside the square root, I can factor out at 45 squared, and then take the square root of 45 squared. I get 45 square root of 45 squared, which is 2025. So 45 squared minus 4 times 4 is 16p. So divided by 2. Now, we know that x and y satisfies this equation. And from here, we know that x and y as positive integers. As we said, x to be m plus 3 and n to be n plus 3. So m and n are positive integers, so x and y also should be positive integers. So this equation should have integer solutions. And for it to have integer solutions, we first need this expression under the square root to be a perfect square. So from here, we can easily point out that we need 45 minus 16p. I need 45 squared minus 16p to be k squared, a perfect square. So this is what we need. So from here, we can just move things around and factorize. We get 16p equals 45 squared minus k squared is just a difference of two squares, which can be factored as 45 plus k minus 45 minus k. Now, from here, we are going to write down all the different ways of splitting up 16p into two factors. So the first way I can do this is also we need to notice that 45 plus k, I mean, is bigger than 45 minus k. So 45 plus k will take the bigger factor. So first way to split 16p is either this takes 8p and this will take 2, or this will take 2p and this will take 8, or this will take 4p and this will take p, and p, I mean 4. And the last one is if this takes 16p and this takes 1. So I'm not going to, you can easily check that the last two cases won't give you integer solutions. So this case and this one won't give you integer solutions. And that you can easily do that, so I'm not going to do it. But it's easy to verify it, because if you just add these two factors, see that 45 plus k and then plus 45 minus k. 45 plus 45 is 90, which is not divisible by 4. So if you take 1 from it, or you add 1 from it, you still get a number that is not divisible by 4. So these last two cases won't give you positive or won't give you integer solutions. So you just need to consider these two cases. Now I'm just going to write down here. So the first case is when p is not p, I mean 45 is when 45k minus 45 plus k, I mean, is 8p, and 45 minus k is 2. So if you add this, and then you see that 8p plus 2 equals 19. Moving things around and then dividing by 8, you see that p should be 11. Similarly, if 45 plus k takes factor 2p, And 45 minus k takes the factor 8. If you add this, you get 90 equals 2p plus 8. And then dividing by 2 and then moving things around, you see that p should be 41. Now, if p equals 11, you get t1, t2 equals, if you put here in this quadratic equation, if you put p equals to 11, so I'm going to put in p equals to 11 here, so it's times 11, so it's p. So if I plug in p equals to 11 here, I get times 11, so it's times 11. I get two values. The first value would be, if I consider the plus sign, would be 1,980. And the second value would be 45. Now, since we say that x and y, are roots of this quadratic equation, so either x equals this and y equals this, or vice versa. So it doesn't matter, the order doesn't matter here, because this equation, the left-hand side of this given equation here is symmetric, because it is that if you swap m and n, then the equation still holds. In other words, to understand it clearly, if mn is a solution, then n and m is also a solution. So if you swap these two pair of solutions, you see get another pair of solution. So here the order doesn't matter. So if x equals 1980, so 1980 is just m plus 3, and 45 is n plus 3, which gives you the pair m equals 1977 and n equals 42. So in other words, you have 1977 and 42, and the permutation, so 42, 1977. And this corresponds to this prime, so this corresponds to the prime p equals to 11. Now for the next prime, when p equals 41, you can just plug in the value, you can see that it will be, you get here, instead of 11, we are plugging in 41. So we are plugging in here 41. So here we are plugging in p equals 41. And here we are getting two values, which are, for the first case, it's 1845. And then for the second case is, if you use the negative version of that expression, you get 180. So for p equals to 11, I mean for if p equals 41, you get t1 be 1845 or 180. So here you can again set this to be x and that to be y. So any order doesn't matter. So 1845 is m plus 3, and 180 is n plus 3. So you see that m is 1842 and n is 177, which gives you another pairs. So 1842 and 177, and also its permutation, so 177 and 1842. And this is for p equals to 41. So all in all, we have, there are only two primes that satisfies this. So let me just write the full solution. So there are only two primes that satisfies this given equation. Those primes are 11 and 41. For the prime 11, so if p equals 11, we have two pairs of solution. So I can say two symmetric pairs of solution. And for p equals 41, we have also two symmetric pairs of solutions. So this brings us to the end of the video. Thank you very much for watching. Hope you learned a lot. And feel free to suggest any alternative solution to this problem. And also feel free to comment. Also, feel free to like the video and share the video. Thank you very much.